So, hi, good afternoon, everybody, and welcome to the fourth day of RIA's Routes to Zero Carbon Rail Unlocking Innovation seminars. We produce these events in conjunction with Network Rail, with the UK Rail Research and Innovation Network, UCRIN, and also with RSSB. We're really very pleased to announce a great range of speakers today. And I think we cover the topic really from a lot of angles this week. So what I want to do is pitch into our first talk. So we've rearranged the agenda a little bit in the last couple of days. And we're going to start off with a 5-minute chat that should have been a pitch, but it's something really important. I think everybody in the industry needs to know about it. RIA has been supporting the Driving the Electric Revolution Challenge as well as the Faraday Battery Challenge. And today we're lucky to have Will Drury with us, who is the Challenge Director for Innovate UK on Driving the Electric Revolution. So Will, can you give us a bit more background on what Driving the Electric Revolution is?
Absolutely, Richard. Thank you ever so much for inviting me to be here and talk about what I think is a really important topic with all of your members and those interested. And I think it's important to put on right at the beginning, we're not focused on cars. I think with a title Driving the Electric Revolution, that can always be a preconception. So we are in the right place. I'm really excited. We are looking at the power electronic machine and drive supply chain, actually making something in the UK. So just to give you a little bit of background on that, we are an £80 million industrial strategy challenge fund, funded through the Department of Business, Energy and Industrial Strategy BEIS, launched last year. So we're still quite a young challenge in that respect, with the focus on the growth and reliance and resilience of a supply chain, which gives the UK jobs and therefore economic growth. I stand by. Power electronics, machines and drives is really the underpinning technology for achieving net zero, from making the energy in the first place from wind, solar, etc., through to using it and deploying it through powertrains. We're talking here about the devices, semiconductors, silicon carbide, gallium nitride, used to actually switch that electricity. The electric machines, whether it's motors, generators, whether it is 12 megawatt offshore wind turbines or mobile or small motors in devices to make them vibrate. And then we're talking about adding intelligence to this. Power electronics are great, motors great, but we've got to add the intelligence. And that would cover charging. It would cover DC-DC conversion. It would cover quality control of electrical energy. Anything that really adds the intelligence to the power electronics system. We cover a huge range of sectors. So I've said we want to do these 3 technologies. In industrial drives, we have world-leading companies here. Robotics, energy I've touched on, but marine, aerospace, rail, both the rolling stock as well as infrastructure, off-highway, auto and personal mobility. And one of the interesting bits for me and really important to our challenge is looking at the cross-cutting opportunities there between different sectors. How can we leverage learning, experience and expertise from one sector into another to reduce the time to market, increase volume, and therefore reduce the cost of those parts? So with that, we are not looking at just providing the funding. We're looking at creating an ecosystem. The funding is there absolutely to do collaborative research and development, but we need to build an ecosystem of people around the country, companies doing that, from SMEs providing tier N services all the way through to the tier 1 and end OEM users, and providing that within a infrastructure such as Driving the Electric Revolution means we can link people together as well. We can work in conjunction with RIA to go, well, actually, these people maybe in off-highway or these people in energy are looking at very similar requirements. Have you spoken to them? Have you connected with them? Really provide more of that investor feel to the money without taking equity, to companies and projects. To that end, we've also invested about £30 million, announced by the Secretary of State back in March, in industrialisation centres, looking at putting equipment in to fill gaps in the current development areas for people to develop manufacturing processes, approaches, and ways that we can do that to bring capability back to the UK, to develop and manufacture things here, rather than doing world-class research in our universities and offshoring final manufacture. How can we do more of that? And through these industrialisation centres, it gives a front door to the entire RTO and academic network, as well as any industrial companies who have equipment in this space that is open access. So a real opportunity and the front door to engage more. Finally, the bit that is of significant interest to people, we've already done £7 million worth of programmes last year. We've already finished, closed, and we are now funding £5 million of short, high impact, high resilience supply chain projects on the back of COVID. And excitingly, and probably of most interest, next spring, we will be doing another £20 million-ish competition of flagship programs, looking at this supply chain growth in power electronics, machines and drives. In addition to that, we are doing work in skills. We have about £6 million ring fence for that. It's going to make a difference. And if people are interested in that or any of the other areas, I would urge you to get in touch with me. My contact details are here. 5 minutes, not a lot of time to cover what is a huge area, but I'd love to speak to you more. So Richard, hopefully I kept just about the time for you. And I thank everyone at RIA for inviting me to be here with you today.
Top man, thank you very much, Will. That's really useful. You also win the Big Clock Award as well there, so that's a great job. Can I just ask you a quick question, Will, before you disappear? We've also been engaged with the Parallel Faraday Battery Challenge. RIA has a representative on that group. Do you have group meetings with DER, and have we got a rail representative?
So we have a representative of Professor Nigel Schofield from the University of Huddersfield, who is engaged with us, who does a significant amount of research in this area. We also have on our advisory group a representative from Network Rail in Dr. Felix Langley. We are open to engaging further. It is not an area we have engaged in.
Well, certainly where RIA members want to engage with the Faraday Battery Challenge, please talk to the technical team at RIA, because we can put you in touch with their representative there. And if we have a member company that would like to represent, say, for example, rolling stock manufacturers or anywhere in the supply chain, which it sounds like you're absent on the group, get in touch with myself or a colleague at RIA Technical Group, and we'll introduce you to Will with the potential to get onto that group with mutual agreement. Thank you again very much, Will.
Thank you very much.
Okay, great. A couple of things I forgot to mention up front, which is around questions. So you'll see a panel on your screen which has got a questions tab. If you want to break that out, open it up and have a look at it, you should be able to work out how to type in and send questions so that we can have those at the end. We'll have a Q&A session wash up at the end. And we need your questions to actually drive that discussion. Also to let you know that you can download all the presentations from the handouts tab, again in that the same panel. So have a look at that. If you don't get round to downloading them during the event and that option disappears at the end of the event, then you'll get an email from GoToMeeting in the next 24 hours or so, which offers you a chance to download the entire recording. And then next week, we'll have all of the slides and all of the recordings available on the RIA website in the innovation community. So the definitive piece of research on decarbonisation, which actually wraps up several other pieces of work, has been done by Andrew Cluth for Rail Safety and Standards Board. Andrew's not available to present today, but we recorded his presentation previously and we can show it to you now. The video is edited and it may not play that well with the large number of delegates that we've got on the call today. We'll see. But in any case, the full version will be shared on the RIA website next week, like I said. So Hannah, can we roll VT, please? Okay.
Hello, and thank you very much for inviting me along to this event. I'm sorry I can't be with you at the moment, hence this recording, but hopefully we'll be able to give you a decent update on what's going on with the RSSB decarb program in terms of the future direction of rail decarb. The decarb activities in the rail industry and the RSSB ago, when Joe Johnson put down the challenge when he was rail minister to take diesel-only trains off the track by 2040. Following that, the industry set up the independent rail industry decarbonisation task force. That was chaired by Malcolm Brown and had representation across the major groups within the industry. It produced 2 reports to the minister in January and July last year, making a range of recommendations which had a fairly fundamental impact across the industry, and the work of the decarb program has built out of that subsequently. RSSB has a decarb research program, which is what I will talk about. Essentially, what the task force did was to look at the evidence for different traction options that may be sufficiently mature within the timeframes being discussed to be able to play a role in a low carbon rail future. We know already that where lines are electrified, that it makes an enormous amount of sense to run pure electrification on those, and there is a very good case for future electrification of certain lines, which is being addressed through the Transport Decarbonisation Network Strategy, and we'll say a little bit more about that in a while, but I know that Helen McAllister has spoken to you about this earlier on this week. We also know that diesel is a substitute for electrification, but it's not a low carbon substitute, even when you're running in diesel bi-mode. So although we know that it can play some role in reducing emissions to an extent, it will not help us towards a completely zero carbon, net zero carbon future. Of the other technologies available, hydrogen and battery were the 2 that were found to be sufficiently mature, or like to be sufficiently mature within timeframes to make a contribution. Neither of these can produce a complete substitute for electrification, but they can play roles in certain types of transportation, particularly on the passenger side, with hydrogen running potentially up to 100 miles an hour and up to 1,000 kilometers range, with battery being able to run up to perhaps in the region of 60 miles an hour over 60 miles at the moment. And then there's a great deal of innovation going on within both of these 2 traction options to try and improve their performance. But in essence, what we see is that where electrification is not going to be justified, that hydrogen and battery will have roles to play in a future low carbon network. With freight, again, the best solution is to electrify. There has been recent research which suggests that it is technically feasible to run hydrogen and battery freight trains, but that there are enormous challenges to how this might be delivered on the GB rail network. So although technically freight routes have been modelled which do allow for hydrogen battery use, there are many more questions to be answered, and they will be addressed in future research programs. But we don't see that there's any real easy solution for heavily used freight lines apart from electrification if we are to decarbonise. The strategic approach then in essence is where we do have an electrified network to always run an electric train, where there's a strong case for electrification to commit to making that transition, and then to make sure that the rail fleet, both passenger and freight trains, are then enabled through conversion or through replacement to run an electrified form on the electrified network. Where we know that we're not going to be able to electrify within the timeframes, we should make an effort at the earliest possible stage to commit to putting in place hydrogen and battery options so that we can deliver against set targets for decarbonisation over the transition to 2040, when we're removing all diesel-only trains, and on to 2050, where we are nationally now committed to a net zero target. The task force looked at 3 key areas. Although we talk about traction being the really big issue, and it takes about 85% of all energy use directly and indirectly on the railway, we also have to worry about infrastructure and property. Infrastructure being very loosely what we require to run the trains, and property being stations and depots. There are some offices in the property side, but the stations and depots are the key issue. We've subdivided those within the task force and within subsequent project work so that we're being clear about the areas we need to tackle. I've said a little about passenger and freight, also about electrification, hydrogen and battery infrastructure. We also need to think about other aspects of infrastructure that support the railway, such as yellow plant and light side generation in place. What we are trying to do is deliver a long-term solution, which means that we have to put in place the right traction options, we have to put in place the right infrastructure, we have to make sure the right buildings are either developed or refurbished as opportunities present. We also need to know that we're actually delivering on what we say that we are capable of doing. Finally, the other thing we have to recognise is that we're not operating in isolation as a rail industry, that we do need to understand that other transport sectors, transport modes are also decarbonising, and we have to ensure that whatever we're doing is working in a manner which doesn't compromise rail's ability to demonstrate it as a low carbon transport option. In terms of getting to the long-term solution, there are a variety of different routes for getting there, and we need to think about transitional arrangements. So we're looking at the use of interim technologies such as bi-modes, looking at the way that you might be able to life extend certain trains where a long-term solution isn't immediately apparent, or where it's cost effective or operationally sensible to either extend the life of the train or to convert it on the way to delivering a long-term solution. With property, we've got to make sure that improvements are being made in the right way, at the right time, in a cost-effective manner. And then within the governance and delivery side, we do know that we're going to have to hit interim targets, both to meet national carbon budgets, but also any requirements put in place on the rail industry to deliver intermediate decarbonisation improvements, as well as to look at step change opportunities such as where fleet replacements do take place. We also have to bear in mind that we're supporting DfT's efforts as part of the national strategy for decarbonisation within the Transport Decarbonisation Plan. There are two or three things I'd like to be able to pick out of this, which we will also be picking up in further research. So one is to look at how any work we do bears in mind the requirement to try to encourage modal shift to public transport. Second one is to recognise that we need to manage carbon in the supply chains and not just directly in the rail industry. And the third one is that we are playing a wider role within a carbon reduction of a global economy. And we do need to make sure that our solutions are bearing that in mind, both in terms of what we can learn from other sectors and also what we can maybe transfer in terms of knowledge to other sectors. We do have an existing programme. I've already covered much of this. The colour scheme here is basically green is complete, amber is ongoing, red is yet. On the left-hand side of that, we've been looking at some of the technical requirements, so passenger traction options, freight traction options, also looking at the standards required for bringing hydrogen and battery powered trains into service. In the middle of that, you can see that we're doing some work on infill electrification for the third rail network, particularly to address safety needs, but also some other elements. And we've also looked at the cost of different infrastructure requirements for hydrogen and battery trains, so that that can support the decision making in economic and commercial terms. There are three projects there, T1197, T1198 and 1201, which have been picking up the thread for decarbonisation. So 1197 has been looking at how much carbon we emit as an industry, where that is sourced from, who might be the guiding hands who are most responsible or most well placed to be responsible for directing how we decarbonise in those areas in the future. 1198 is supporting DfT, providing advice and guidance from the industry to DfT in terms of the feasibility of setting intermediate targets en route to the long-term targets that DfT will have to specify. And that's looking, as I say, with items such as national carbon budgets, control period funding, what may happen as a result of the Williams review, if that information comes out in time, and what will be opportunities for incremental changes through just natural improvements and also step changes in target setting. But that will also be picking up on the metrics that we might be using. 1201 finally will be looking at the mechanisms that may be in place already or that may be feasible, both existing within the industry and outside the industry, for incentivising decarbonisation. The research that has been undertaken and coming out of the final report and within RSSB isn't just sort of disappearing into a pit. It's being used actively by a number of different organisations. So Network Rail's Traction Decarbonisation Network Strategy has been identifying issues which we're now addressing. Similarly, the Transport Decarbonisation Plan has been informed by and will inform research within the Decarb 2 programme. And in the research that we've undertaken, either directly or indirectly, and we have spoken with national organisations such as the Committee on Climate Change, which has helped to inform national targets. And we are working with others such as the Technical Leadership Group, developing and managing the rail technical strategy, and also the whole industry strategic plan, which DFT has asked Network Rail to develop, where we are contributing to the whole industry environmental sustainability strategy. Landscape. What I wanted to be able to do was just show you the kind of range of different initiatives and stakeholders that are involved within this process. It's a collaborative effort, and we do require a really good relationship between all of these separate groups to make sure that we're delivering in a timely and cost-effective and technically feasible reporting. And the Minister has recently asked the task force to continue to provide guidance in the delivery of the rail industry's decarbonisation programme. So we have also been doing other work within RSSB through other sources of funding. I just wanted to highlight that there's been sort of first of a kind funding in certain areas, and there have been three in particular which have been really interesting around high-speed passenger trains, freight and infrastructure. The projects on the right-hand side were genuinely feasibility studies, but looking at the way that we might be able to use renewable energy on the network, how we might be able to optimise route carbon, and how we might be able to optimise system-wide carbon. And those are just at very early stages, but one thing that it has done is generate a lot of new ideas, and you'll see that we've reflected those in the work that we're doing in the future. So what we are trying to do is to identify gaps in the knowledge and skills within the industry and start to identify how we may be able to plug those, where we're working on cross-cutting issues involving two or more entities within the industry, where it's not obvious that any one of them can deal with it on their own, so that there is a degree of cooperation involved, and that we are focused on the short to medium term, but that we carry on bearing in mind the long-term requirements, particularly in areas where we're supporting other work streams such as TDP and TDNS, but also giving opportunities for members of the industry to be able to develop their own knowledge and understanding, either through consulting work they may be doing or participating in steering groups. And we appreciate that these are relatively small projects, but they are giving very strong indicators as to where the industry might have to head in the future. So if anybody's interested in sort of getting more involved in these, we'd be delighted to hear from you. What I would like to then sort of focus up is that there is a logical flow on the left-hand side. I've just highlighted all these projects that we've got ongoing. In the middle, there's 4 projects which have been funded for Decarb 2, which is going over from now until 2021. These were generated from task force findings, from workshops we did earlier on this year, from ongoing consultations we're doing within the industry, from conferences like this where people give us feedback, and also from questions being raised by previous projects. But the individual entities within the rail industry, as they decarbonise themselves, are aware of their context within the industry decarbonisation, because the industry has been asked to produce its net zero planning, not individual entities. We just need to make sure that there is a clear picture for individual entities to work against, and that it makes sense and we can coordinate within those areas. On the supply chain side, we're trying to make sure that anything we do in terms of decarbonisation with the industry doesn't then trickle out and have negative impacts outside the supply chain. Most of our impacts are actually in the supply chain, but they're indirectly managed, and we need to just get a better handle on that. Within low carbon freight, I mentioned earlier on that we've got technical solutions, but we need to consider the practical implications of those in a lot more detail before we can say with any great certainty, apart from electrification, what role other low carbon traction options have within freight. And finally, on low carbon train design, it makes sense to design out carbon in the first place. So we're looking at things like streamlining, lightweighting, improving the efficiency of onboard systems, and so on and so forth, and seeing what we can do to make sure that both the trains and the supporting systems that they have are minimising carbon in the design phase as much as possible. On the right-hand side, I mentioned we've done ongoing consultation. Those feasibility projects have also fed some of the ideas. We've had feedback from Network Rail on their sustainability strategy and from other organisations in terms of areas where they would like to be able to see further work. And so those ideas of the future are there for the time being, but we'll be consulting on those probably early next year to see which ones are the most likely to make sense to fund for the Decarb 3 phase of the overall work programme. In those areas, you can see they're getting significantly more complex and involved. And the other thing that is apparent from this is that some of these issues are dealing with impacts that happen outside the rail industry, where we will have to cooperate and collaborate with non-rail industry bodies to make sure that we're dealing with this in the best way possible. So in keeping with the theme of this conference, I think that the challenge is going to be, how does rail industry integrate into the wider transport sector and into the wider UK infrastructure in terms of how it manages its decarbonisation, both in terms of where it can benefit from what's going on within other parts of the economy, and also where we can pass learning into the economy as a whole, particularly where we're trying to make sure that we're integrating as part of a sustainable transport system. And those would be the markers I'd put down for you for consideration in future development of decarbonisation in the rail industry.
Okay, right. Good. Thank you very much, Andrew. Even though you're not with us, that was a great job. Just to say, remind everybody that you'll be able to download the whole unedited piece from Andrew there on the RIA Innovation Community on the RIA website, riagb.org.uk, from next week. So give us a few days to post all that up. So as Andrew alluded there, the rail industry does not live on an energy island. We're largely dependent on the national grid for our electrical power supply today. But the future could be different. It could look quite different. And Dr. Russell Fowler, who works in transport decarbonisation at the National Grid, is here to tell us more about their full capabilities. So, Russell, can I hand over to you, please?
Yes, thank you, Richard. Thank you for that handover. That was a really interesting presentation. Like I say, thank you for the opportunity to speak here today. What I hope to do is give an energy networks view of this. So first, I'll apologise if I'm not a transport expert, but I'm an energy expert there. So please forgive me for any basic errors that I may make there. So let's get started. So as Richard said, so who are National Grid? A lot of people will probably know this, but it's always worth just going over quickly who we are. So first, we own the pipes and wires across the country. And by this, we mean the high voltage, high pressure wire and pipe. So you can think of these as the motorways or A roads of the network. So we take from electricity, which I think will probably be our focus here, but we also do look at gas as well. These will be the wires that will take the electricity from the power stations, then to the smaller local grids, which will deliver it to your homes and businesses. There are some examples where we do deliver electricity directly to the customer. Network Rail, the rail industry is a classic example of that, where energy moves directly from the national grid to the rail networks. You can see some interesting statistics there. One of the things that we're quite proud of is our very high reliability. In the UK, the electricity transmission system is very, very reliable. That's something we're quite proud of. We also have a system operator part of the business. This is a separate, legally separate part of the business. So they're the part of the business that balance supply and demand on a second by second basis. They're the people you'll often see on television. They have a very grand control room, and they will talk about things like TV pickups and what happens when major sporting events will go on there. So they're people that will do the kind of day-to-day operations of the system. I'm in the part of the business that owns the physical infrastructure, just to make that distinction there. So first is transport and national grid. So why do you have a team that looks specifically at transport, which is my role? So if you're going to decarbonise the UK economy, you know we have this 2050 goal of reaching net zero. how are we going to achieve that? We have to effectively decarbonize every single sector of the economy. As you can see by this chart here, around 2016, 2017, transport became the largest emitting sector for greenhouse gas emissions. It actually overtook the energy sector, which has been on a rapid downward trajectory over the last 10, 15 years, thanks to the uptake of solar and wind generation and the removal of coal generation from the system. So if we're going to decarbonize the UK, we need to decarbonize transport. Also in the box there's also kind of air quality issue here. Transport is responsible for a lot of air quality issues. I won't dwell on some of the statistics there, but improving the quality of the air is something that should be really important to everybody here. And when we look at transport, of course, people will say, well, cars absolutely the focus. You need to get cars off petrol and diesel and onto electricity as well. Absolutely, and that is the focus. But because we have a net zero target, we can't ignore other forms of transport. And again, as passenger cars start to electrify, you've seen the uptake of electric vehicles, the onus will then become on other forms of transport to decarbonize as well. And we will become left with kind of increasingly more challenging areas to decarbonize. And you also potentially picking up a kind of modal shift where you may see more freight, for example, moving to rail, and rail becoming a larger percentage of the overall transport emissions. So absolutely the focus needs to be on all areas of transport, not just cars. So that's why we're interested there. I'm not going to spend too much time telling this audience kind of what infrastructure already exists at the moment. What I will do is kind of put a little bit of an energy lens over the top of that. When we look at the rail system, we see a significant amount of it already electrified. We have around 42% electrified. And when we look at rail decarbonisation strategies, I'll pick up the TDNS, for example, here. We see it looks like significant further electrification will be required to meet those decarbonisation targets. And we know how that can be done over overhead lines or third rails. And this is something that National Grid already serves as supplier of infrastructure and electricity to Network Rail already. And this is already operational and this is already proved, and we know how to do this. This is almost a little bit business as usual. So it's a little bit more interesting about, well, what about the parts of the network that can't be electrified like that? And the two solutions that come out, of course, are hydrogen and battery. Both of these are possibilities. Of course, we saw the first hydrogen train on the UK rail networks relatively recently. We're going to hear more about that later. But of those two solutions, neither of them are perfect in terms of they can't do everything necessarily by themselves. So are we going to see a kind of patchwork of all of these solutions? So kind of electrification, batteries and hydrogen. That's certainly how we think the rail network will look from an energy point of view. So let's kind of look at those in a little bit more detail. And of course here, I won't touch too much on the overhead catenary there, kind of we know what's going on there. But when we look at battery, we kind of see this as looking at where overhead lines are harder to relocate. So it could be simply a gap in overhead lines. So for instance, a tunnel or a piece where the local geography is maybe not set to deliver overhead lines, or it could be an entire line that could be run by battery. And the question you have here, which we'll touch on a little bit on the next slide, is, well, if you have batteries, you need to charge them up somewhere. So absolutely we do. So let's hold that question in our mind, and we'll come on to that. Again, for hydrogen, again, suitable for large areas of countries where overhead lines or batteries just simply wouldn't be practical. And again, it's worth touching on here on the hydrogen, that if this is to be truly net zero, if we were truly to remove carbon emissions from rail, this needs to be either green hydrogen or blue hydrogen. I'll touch a little bit more on what these are on the next slide. So again, I'm going to put my energy lens on the top of this. The first point is kind of really clear. National Grid, we're kind of technology agnostic here. So we have an electricity transmission business. We also have a gas transmission business. We also active in the hydrogen world as well. So we have no particular area that we want to push, or we think actually this is what you need to do. We're very keen on saying, well, this is a transport challenge. How can the energy networks support that? Again, catenary, we kind of know what those solutions look like, so I'll jump over them. So in terms of battery, this is all around where are you going to charge your trains up? And kind of we see a few models out there as either kind of dedicated charging hubs or hydrogen depots. Is there one large central locations where you would do all of your charging? Would it happen at stations, or would it even happen along the kind of network itself? And these will kind of dictate about what connections you want. If you're looking at large centralized charging hubs, connections to a transmission system are probably the solution that you're looking at there. If you're looking at smaller connections, then it may be the distribution network is the solution for you, or actually maybe more innovative solution. Do you actually need a network connection? Can you manage this with smart charging, maybe with additions of solar or battery to manage the load there? So again, depends exactly on what that load looks like. For hydrogen, I mentioned hydrogen's obviously got to be clean for it to work. So this is green hydrogen, so hydrogen produced by electrolysis and powered by renewable energy, or so-called blue hydrogen. So this is hydrogen produced from kind of normal industrial means, but that carbon is captured, stored, or used somewhere. Now, we believe in the kind of short to medium term that green hydrogen, so electrolysis with renewables, will produce the majority of hydrogen. We see this with road transport, that hydrogen is often produced very locally, so very close to the fill-in stations, if you like, for hydrogen. And we see this as a model that could be extended certainly to rail as well. So are we going to see hydrogen charging refueling stations at depots as well? And again, there needs to be kind of energy infrastructure to support that. Briefly worth touching on kind of intermodal hubs as well. So there is a potential that rail and road could interact. So you could see freight going from one to the other. And when you look to decarbonize both of these sectors, there is a kind of natural synergy that you're going to have a significant amount of energy required at that charging hub. So charging trains, charging hubs, producing hydrogen for road vehicles and producing hydrogen for rail at the same time. So absolutely, this is something that needs to look across not only energy, but other forms of transport as well, to see what is the most optimal way we can make use of energy infrastructure, kind of minimizing disruption and kind of looking at improved land use. So kind of summarize up here. So grid infrastructure will need to enable this future. Electric energy infrastructure in particular will be critical to this, either the direct electrification, charging batteries, or for that production of local hydrogen. I'm thinking about grid requirements up front. It takes time to deliver all infrastructure, as we know on here. So we need to be thinking about the rail solution and the energy solution in parallel so we can get that cost-effective solution. And key to that absolutely is collaboration. This will be key. We've already noted that from previous speakers here, but I will kind of echo that from an energy point of view. We're really keen to work with people in the rail industry, how we can help as energy networks to decarbonize the rail industry. So I will move on to my final slide with my contact details. So I'll be more than happy to take questions in the Q&A or for people to contact me and carry on this conversation. Thank you very much, Richard.
Thank you, Russell. That's a really useful talk to get us thinking more widely about this issue. It's not just a rail issue, it's a much wider issue. I'm going to just pop in a point here that although Andrew Cluth wasn't able to be with us and we had the recording, we do still have some representatives from RSSB. So that's Yulia Lorenzini and James Wright. So you can ask questions as if you were asking Andrew, and they'll do their best to field them. And if not, they'll take them back and get some answers and come back to you. Now, I mentioned earlier our links with the UK Rail Research and Innovation Network, and the next speaker is Dr. David Golightly of Newcastle University, which is part of that Ukraine network. And in fact, you've been working on a project funded by RSSB, David, is that right?
Yes, that's correct, Richard. Thanks very much.
Okay,
That was a very good link.
Okay,
Sorry.
I'll leave you to tell us more about that, David. Over to you.
Yeah, thanks very much, because it was very well linked into Andrew's video earlier. We're one of the feasibility projects that Andrew mentioned. So from the outset, I'd like to acknowledge RSSB's funding and say thanks very much to them for their support on the project. So I'd like to talk about the digital environment for collaborative intelligent decarbonisation, DECIDE. I'm part of a team which includes Ken Pierce from computer science and also Roberto Pallison from engineering. So what is the problem we're looking at? Rail decarbonisation is a systems issue. then we need to think in a joined-up manner to deliver the best and most cost-effective decarbonisation solutions. Simulation is key to modelling, but system simulation modelling is challenging. First, systems modelling involves combining multiple simulation models together, which can be complex, time-consuming process. And this is amplified when the models use different formats, which is particularly the case when we're trying to introduce models from outside a rail. We have the problem of IP, with vendors often reluctant to share their models in their entirety because they may be giving away some of the details of their products. And finally, there are the logistics of sharing and combining models when suppliers are geographically dispersed. So the solution, as we see it, is a collaborative platform for combining models. The heart of this platform is functional mock-up interface, a standard in common use in automotive, aerospace, and cyber-physical systems that allows you to wrap a simulation model in a way that makes it interchangeable with other models, but without exposing IP. Models are run together using a co-simulation engine, such as the one we use into CPS. This can generate versions of models wrapped using FMI. These are called functional mock-up units. These models can be of radically different types, so we can combine discrete event simulation, which might model something like the state of interlocking or the signaling system, along with continuous time series, which might be more appropriate for phenomena such as power draw or traction performance. Inter-CPS can synchronize these model outputs together, run them in parallel. And importantly, this environment allows us to change parameters, combine models in different ways, and compare results. While co-simulation is the heart of our project and what I focus on today, we also examine potential for delivering co-simulation through a cloud-based marketplace, concept from the simulation community, and also allows customers to rapidly explore multiple supply chain options. Also, we spent much time talking to rail representatives as well as experts in FMI from outside of rail. So, anticipated benefits. Implementing qualitatively different model types. Combining diverse models in a single simulation environment to generate systems effects. Rapid reconfiguration of the multi-model for design space exploration. Rapid integration of external models from suppliers to understand different design solutions. Supporting rapid porting of models to a new rail context to deliver flexibility. Some industry perspectives from our stakeholder engagement. There's almost no current use of FMI, but there is an appetite for more flexible micro simulation and a need to update existing simulations. Core systems applications may already be well addressed, but are somewhat inflexible at the moment. And there's a second tier of applications that may not be modeled at all at the moment that could be open to FMI. Plenty of use of MATLAB Simulink at the model, and that is a format that's already FMI compliant. But there are challenges around data exchange and also lock-in with proprietary simulation packages. From outside of rail, FMI is emerging and flexible and responsive to needs. It's critical for optioneering and right first time. It's driven by OEMs, typically organizations say BMW or Airbus. There are new markets that it's entering, such as offshore propulsion, and it has applications to digital twin. So what I'd like to do next is talk a little bit about some examples of implementation. Start with, we developed 4 models based around a section of infrastructure and rolling stock from a tiny Weir metro. FMUs included a movement authority model, which represented infrastructure and 2-aspect signaling, and interlocking for a section of the network between 2 stations. We had a driver model that responded to the signaling with power and brake. There's also a train model with braking, motor, and so on. And finally, we modeled a simple external power supply. For metro, this is 1.5 kilovolt overhead line. A few things to note. We decided to have 2 trains and therefore 2 driver models in our simulation, so we can see how one train's behavior could influence another on the same stretch of infrastructure. Also, we developed 2 different types of train and driver. There was a baseline version of the train based on current metro weight, but then another that was light-weighted and had regenerative braking. There was also a second version of the driver that was more reserved in power and brake usage, thus mimicking a kind of a defensive or energy-efficient driving style. Here is the simulation output for the simulation run using the energy-efficient rolling stock and defensive driving style with 2 trains. Clockwise, this is the train position for 2 trains, the driver action for 2 trains, energy usage for the 2 trains, and the speed for the 2 trains. In the bottom right, for example, you see the orange broken line dips down again. This is where regenerative braking energy is harvested as train 2 brakes on approach to the station. We ran 4 variants of the simulation, varying rolling stock type and driver type. The graph shows cumulative power for the 4 conditions, and you can see the blue line, which is the energy efficient driving and energy efficient rolling stock. You can see there that cumulative power is the lowest of the 4 conditions. It's not surprising. We can also see that it takes longer because of the defensive driving style. In this way, co-simulation shows both how we can trial different configurations of a system and the kind of systems interactions that we then wanted to show that we could add a third-party model. We were able to take a third-party MATLAB Simulink model of a battery and plug this in as a replacement for our overhead power. Here are the outputs for train speed and battery draw. It's an 800-volt battery, so trains run about half the usual speed, which may not be operationally realistic, but shows we can rapidly integrate a third-party model, particularly for Simulink, which is a common simulation tool. Going one step further, we wanted to show how we could rapidly move from a simple urban model to a more complex mainline model. Now we've only implemented 1 train and 1 driver type, but we've ported our models to a mainline context. In our case, a simplified East Coast mainline from Newcastle to Durham, changed to a 25 kilovolt overhead electrification, suitable vehicle parameters for something like a Class 800, and implemented 4 aspect signaling. And so our driver has been adopted so that it coasts, reduces power and brakes in relation to the state of different aspects. So skipping to the summary, we have FMI and co-simulation for rail decarbonisation system simulation. We have the ability to model systems behaviours. We're able to rapidly reconfigure, able to integrate third-party models. There is industry opportunity, but some challenges to address, and we're able to simulate human performance and driver behaviour. And to conclude, as Andrew mentioned, we have thought about how our work fits in with the work of Loughborough, who presented earlier in the week. They've got their validated Class 800 model, which gives accurate CO2 estimation. We are looking at a 3-stage plan working with Loughborough to first wrap up their model with FMI, then make it scalable for any route, and then the 3rd stage is commercialization and make it system-wide. So if you want to know more, there's some more details and outputs there, please drop me an email. Okay, over to you, Richard.
Thank you very much indeed, David. That's a really good guide to just some of the research going on in Newcastle and elsewhere. Now, I'm very pleased to introduce a presentation on an exciting and practical piece of innovation, which is Tyseley Energy Park in Birmingham, and how it's supporting rail innovation in conjunction with Birmingham University. So it's a great collaboration. Here is David Horsfall, Director of Property at Tyseley Energy Park, and Stephen Kent of the University of Birmingham, who's going to start us off. So Stephen, over to you.
Hello, good afternoon, and thank you for the opportunity to speak. I'll at the outset again thank RSSB for funding certainly a lot of the things that I'm about to talk about. So it's called Birmingham's Hydrogen Hub, so we are going to be talking a bit about hydrogen here. Now, the first thing to mention is you may have seen this already this week, you may not. This is the RSSB T1145 piece of work that we were also involved with. And just to emphasize why hydrogen is important and how it fits in. So if you look at this graph here on the right, it's discussing how many kilograms of CO2, E means it includes other gases, you produce per kilowatt hour of energy consumed by a train. And in red there, you can see at the top is diesel, taken as our benchmark. Now, yes, you can improve diesel technology and make a bit of a difference, but if you really want to reduce CO2 emissions using national grid electricity, it's already substantially better. That's the yellow bar, about the fourth one down. By 2040, really, national grid electricity is going to be very low carbon indeed, which is wonderful. Now, of course, batteries are fine. They, round trip efficiency into and out of the battery might be 90%, so they're almost as good as electrification, but there is the problem with range and speed for batteries. We looked at alternative fossil fuels, things like LNG and CNG. No real great shock here. There's no great advantage from a CO2 emissions point of view. And then we go on to my pet topic, which is hydrogen. Now, if you make hydrogen using natural gas, it's not a big improvement in the situation. And indeed, if you're using just grid electricity at the moment, it's not that great either, but it will be by 2040, such as the rate that the grid is being decarbonised. So we're talking here of electrolysis. And of course, if you use green hydrogen, so electricity that's come from a renewable source, your carbon drops to very, very low, almost zero. So hydrogen from electrolysis can be good, and it's going to get better and better. According to Network Rail's Traction Decarbonisation Network strategy, they've taken this on, obviously, and electrification really is the key way to go forward, but hydrogen is also part of the plan. Now, I suspect some of you have already seen this, but I'll show you a short video clip. This is the joint effort by University of Birmingham and Porterbrook to develop the UK's first hydrogen fuel cell powered passenger train. And this is it actually running on UK mainline last week. So this is breaking news if you want. So this is Helen Simpson, who led the project from Porterbrook's side, and took the vehicle through an awful lot of safety approvals to actually get us to this point. So it's effectively the critical point here is hydrogen trains are approved for running on UK infrastructure, and that was Stuart Hilmansson who led the work from our side. I like to see the steam coming out the side of that. Anyway, so that is a hydrogen train running on the network. So moving on from there, of course, we need some hydrogen. And let's just see if this will click forwards. There we go. So what are the hydrogen supply requirements? Of course, it's got to be low carbon. So we're talking produced from electrolysis. We're going to say for the time being that carbon capture and storage is on the horizon, but it's not here anytime soon. So we are talking electrolysis. And of the requirements, one of the key ones for the railway, of course, is we've got to have a reliable supply of hydrogen. If for any reason your equipment that's making the hydrogen falls over, you've got a big problem. No hydrogen equals no train service. And yes, you can store quantities of hydrogen, but not in the same way that a diesel depot might store maybe 3 or 4 days diesel on site. With hydrogen, you're talking a day or two at most. So your production system has to be very reliable, and thankfully, certain of the bus fleets, their electrolyzers have proven to be extremely reliable, so that's helpful. But we're also talking big quantities of hydrogen here. So Birmingham's bus fleet is going to need round about 600 kilograms a day of hydrogen. That's the bus fleet shown there to the right. The order, I think, is just being placed for these lovely double-deckers from Wrightbus. But a typical train fleet, you have an order of magnitude higher here. You're talking for 10 3-car multiple units doing, say, 500 miles a day, you're talking nearly 3,000 kilograms of hydrogen per day. Now that needs something near a 10 megawatt electrolyzer. Now again, 10 megawatt electrolyzers are already being installed in various places in Europe. So that technology is doable, that technology is available. Now on to the next slide. This is interesting. You want to produce your hydrogen, your fuel, near your refueling point. That was mentioned by the talk by the National Grid. And just to ram that home, if you get hydrogen delivered by road, let's first look at diesel and take that as a benchmark. So a single heavy goods vehicle can deliver enough diesel to refuel at least 20 regional trains, possibly a bit more, but at least 20. Because of the nature of hydrogen, if you're delivering it as a compressed natural gas, that same HGV can only carry enough hydrogen fuel to refuel just 2 regional trains. Delivering hydrogen by road for a fleet of any size just doesn't make sense, because your HGVs can be running on diesel for one thing. And then we get on to the question of money. Now, at the moment, the railways run reduced duty diesel, so we're talking around about 60 pence per litre, and a typical regional train, something like a Turbostar, will use a litre a vehicle a mile, so you end up with 60 pence per vehicle per mile. Now, if we look at hydrogen, if you want hydrogen to match that pence per mile, you need your hydrogen down at about £3 per kilogram. And if you know anything about hydrogen prices, that's quite ambitious. And the reason for that is you're talking at needing electricity very approximately around 2 pence per kilowatt hour. Now, if you look at your domestic bill, you'll be paying 14 or 15. Network Rail pay around about 8 to 10 pence per kilowatt hour. So we're quite a way off this. But one of the things that's interesting is that if you're to get anywhere near a sensible price for your hydrogen, you want to ideally generate your electricity locally, and that avoids your grid fees and your taxes. Now, grid fees and your taxes alone are going to be more than 2 pence per kilowatt hour. So it's interesting that it would be perfect if we could find a source of electricity near to a railway depot where there's room for hydrogen production equipment. Now, of course, there is some speculation about whether reduced duty diesel will carry on being available for industries such as agriculture and construction. That could happen to the railways, and if the railway no longer was allowed to run red diesel, we'd be talking about £1.10 per vehicle per mile. Now, at this point, hydrogen, now we're talking about £5.60, very roughly speaking, per kilogram, gets you parity. And that's electricity around the 6 pence per kilowatt hour mark, if you will. So if you bear some of those numbers in mind, I'm now going to before I move on, I'll just point to that report there on the right. That's on RSSB's Spark database. It includes quite a lot of useful information in there about how you maintain and refuel hydrogen fuel cell powered trains, and the information that I'm drawing upon for this presentation largely comes from that report. I wrote it. I think it's quite well written, certainly been well received, so do please have a look. It's well worth spending half an hour having a quick flick through. But I'm now going to hand over to David Horsfall, who's the director at Tyseley Energy Park, to say what they've got to offer us being the railway industry. David, are you there?
Thanks, Stephen. Yes. So I'm just going to talk a little bit about Tyseley Energy Park and build perhaps on what Stephen's been saying. So just as a bit of context, so Tyseley Energy Park was born out of my family business. It's 300 years old, manufacturing wire and wire rope in the red outlined area just to the left of the page. We're technology agnostic. We're repurposing our land, and we're bringing that forward for an energy park. I guess the best way of describing Tyseley Energy Park, which is the name we give to that part of our group, is a collaboration between the public and private sector, as well as academic institutions, of which one of those key ones is the University of Birmingham, hence the kind of joint presentation with Stephen today. We believe that heat, power, transport, waste is something that should be joined up, and so we're looking at sort of energy solutions. It was really interesting to hear Andrew Kuth earlier talking about integration of wider infrastructure, sustainable transport systems, and likewise with Russell talking about internodal refueling hubs. It's exactly what we've been developing at Tyseley Energy Park, with that in mind, a refueling station that's publicly accessible, being technology agnostic, having lots of different fuels there, all underpinned by renewable power. What this slide shows is that there's lots of potential users. So there's businesses, there's Asda in the top left there, but there's 250 businesses in the area, all with sustainability goals. You've got a transportation hub in the middle. You've got RCV fleet, and then you've got Tysie railway station on the right-hand side, and you've got 3 large energy generators there at the moment. So we've got 10 megawatts on our site. Number 1 in the middle of the page is the energy from waste plant for Tysie, which produces 25 megawatts of power. 3 is another 25 megawatt plant that's in the pipeline, and there's about another 40 megs in the system as well coming forward, which could be used for putting power into the grid, or could be used for decarbonising heat, or it might be used to create a transport fuel. And it's kind of, that's really the discussion we all need to have going forward. How do we use our generating assets going forward? What's the best application for them? On Tysie Energy Park, we've been lucky enough to be involved in a project which will involve these buses that Stephen mentioned. So having a back-to-base vehicle that underpins your refueling infrastructure is amazing. Likewise with RCVs, there's lots of discussions going on about what the future of the RCVs are and what's the optimum fuel for them. But likewise, the railway industry, having certainty about the amount of fuel that's going to be used, the term that you're going to use your vehicles for, that's so exciting, because it enables you to invest in infrastructure that could potentially enable that wider expansion. If you can be thinking about this, the idea of the internodal refueling hub, where maybe that the fuel can be used for other purposes like road transport or heating, and that's something I think we all need to be thinking about as an energy system. Stephen, if you don't mind skipping on to the next slide. So on site today, we've got a 3 megawatt electrolyzer. ITM Power have built that, and that will be refueling those 20 buses. We know that there's spare capacity in that, and the sort of spare capacity might be enough to refuel, say, 2 to 3 trains. Hypothetically, wouldn't it be exciting if you started a trial? It's not beyond the realms of possibility to take a tube trailer from our site over to the railway station and be refueling a small amount of trains to sort of prove a concept. And then also thinking about those generating assets, if you had 100 megawatts of power, that could refuel sort of 200 to 300 trains, which clearly you probably wouldn't want to do because of all the things Stephen mentioned, not least storing large volumes of hydrogen. But if there was a case for hydrogen, and we agreed that producing a multinodal refueling station like this that benefits other people is a good idea, wouldn't it be exciting to all plan for this and do something in a location like this where you've got a large amount of renewable electricity? This isn't unique. I'd say that there'll be other sites across this country where you've got assets alongside Network Rail assets, where there might be waste streams or renewable power from wind or other renewable assets. So I guess the challenge to the rail industry is we need to start thinking about how we can identify these assets and how we can start thinking about energy systems that enable the growth of infrastructure, not just for rail, but other transport or decarbonisation of heat. Thank you very much for letting me speak today, and hopefully you can see on a very small scale, like, you know, our family business in collaboration with partners are trying our best to prove things and take some risks and probably make some mistakes along the way, but hopefully there'll be some learning that everyone will benefit from as well. So that's probably me.
Good, thank you very much. That's a brilliant ambition, David. I absolutely love the project, and you know, hope I'll be talking to you about that later on after the event, actually. Thanks to both there, to Stephen and to David for that. On to our 5-minute pitches, and we're slightly altering the agenda and just changing the order. So first of all, there'll be few people in the industry who don't know Rebecca Sellick, but perhaps not everyone knows that what she's doing currently. So we're pleased to give Rebecca the opportunity to update us all. So Rebecca, would you like to take over, please?
Certainly, thank you, Richard. Hello. Yes, I've been around for a long time, 30 years, a railway engineer, and still having fun. But I wanted to add something a bit more radical today. So we've heard about hydrogen and the batteries, and hydrogen, oh, that's so old hat. So I wanted to see where we might be going beyond that. So it's routes to zero carbon rail and zero carbon transport. And as Russell Fowler did from National Grid, I've got some remarkably similar graphs coming up in a minute. So let's see if we can move on the page. Right, there's this famous delay in the page moving on. So my first thing is about, we get terribly excited. I can have a hand with the page move on. Is it going to happen? About, it's all going through now. Thank you. Great. We've doubled the amount of passengers that we have in the railway industry, how much we deliver. But if you look at the whole transport in the UK over the last 50 years, then you can see that, so what? That rail is that orange stripe, the second one up there, and yes, okay, it's doubled, but the green blob is enormous, and the green blob does much more carbon as well. So if we look at that, my graph on the left there is very similar to the one that Russell showed. Thankfully, we have the same stats, which says that transport, although we cause fewer emissions, we used to cause fewer emissions, we've not got significantly better. We've not really changed in the last 50 years. 30 years in terms of how much carbon we're actually causing, how little we are decarbonising as a sector. And yes, a lot of that is cars. He mentioned about freight modal shift, and I think that a more exciting challenge is the car modal shift, because it's not just how cars are fueled in terms of electric because of the particulates from the rubber tyre on the road, as opposed to our nice clean wheel on steel on steel interfaces. So one of the projects that I've been doing, just to share a few of them, that's like radical for the railway industry, is why car? Encouraging people to ask, it's a bid at the moment, to ask people to ask themselves why car. It's rather than looking at that incremental marginal journey when I've got all these sunk costs in my car anyway, and so I'm looking at the petrol versus the bus fare versus the train fare, and I'm saying, well, it's not really worth it. If I were to look at the whole cost of my car and say, do I need that car, do I need a second car, do we need to do things this way, to try and promote some more holistic pro-planet decision-making stuff. So that's a kind of just do it. Let's very easy win on transport decarbonisation if people change mode from a more heavily polluting mode to a significantly less one. And then I've done some work with cleaner diesels that haven't been mentioned during this conference yet, so as far as I'm aware, but sort of catalytic converters, making what we've got now immediately loads better. So that's unlocking that benefit from retrofit projects. And then, yes, I've done some work on hydrogen battery stuff as well, and it is very exciting, and I am not decrying that in any way. But what I wanted to offer as something more was my fourth and fifth ones on my list there, something very different in terms of flywheels that can really change the battery life thing, because people haven't mentioned what happens after the battery's over. Battery life, not as long as train life, certainly, and what do you get left with at the end of that, and that sort of question. Whereas a flywheel could radically change the battery life. This is something that's under development. I want to show in the next few slides. And ActiWheel, which is a whole system game changer. And actually, I've just been to an IMechE seminar about that. The Institution of Mechanical Engineers ran that, so I'll kind of I recommend signposting to that. It's a really radical game changer that I've been involved with too. So my next slide just tells you about the premise of a flywheel. It can smooth out. We can effectively make a diesel or a self-powered vehicle regenerative by capturing the energy on braking or coasting and then using it for extra oomph. So we need a smaller energy supply to get going when we need a bit of accelerating. So this is a particularly nice flywheel that we have here because it's made out of carbon steel. So it's just very straightforward, and it's cheap and cheerful, and it's robust. And you know, to the very old railway engineer that I am, thank you, Richard. It's the layers of laminated steel are something that we're quite comfortable with having on trains potentially, or under trains, and because you can get a worthwhile amount under a bogie there. If you look at the little diagram on the the right of the screen, you can see the purple flywheel mounted there. It's in that sort of scale of things that can deliver this 30% fuel saving and 30% downsizing, which means we're using less of whatever fuel we're using. So that whole efficiency that then obviously drives the decarbonisation agenda. So this is some work done with City University and others, making this project to the point where an RSSB sponsored project, another shout out to Andrew Cluthelot, to create something that may well be worthwhile. And there's another way that we could use this. We don't have to stick it on a vehicle. We could look at line side applications. That's where there might be some ways that might be interesting for the national grid, where it's more challenged in providing the very significant load that rail electrification is asking for, that Russell Fowler might be interested in that kind of smoothing sort of activity, or in making Birmingham New Street clean, for example, so that there's very quickly those diesel trains can turn off and the flywheel can help them through. And on my last page then is about ActiWheel, which is this really radical difference of saying, well, we don't need coned wheels. We can have little independent wheels and go around corners really easily. And talk about lightweighting vehicles. This will really radically lightweight vehicles, because we don't need pneumatic systems. We don't need brakes. We can brake on the little motor that's mounted on the wheel. And that's got, with my chums from Loughborough University and Huddersfield University, has got to proving on a heritage line. It does go up and down, and it's how to get that game changer out there in the industry more radically.
Thank you very much. Sorry, that was a scamper. Did you have anything to say over that last slide, or is that just a contact slide? Great, job done. Certainly, I'm with you on ActiWheel. Not that I'm not with you on anything else, but particularly the SET ActiWheel. That's been knocking at the door for so long. So come on, industry, wake up. Let's go with that one. Okay, so to our last pitch now, which is John Constable, Group Technology and Engineering Director of TP Group. So John, you've got your camera and your mic on, please. And John's company are bringing some great knowledge in hydrogen from other sectors. So John, can I hand over to you?
Yeah, of course. Thanks, Richard, and hello to everyone. Good to be here today. 5 minutes, not long, so I've got to step through quite a lot quite quickly. So TP Group have been involved in green hydrogen solutions and carbon capture systems for around 60 odd years. And actually, now what we're beginning to do is to turn our focus into the rail sector, as the rail sector is moving towards decarbonisation, as many other sectors are. I'm waiting for my slides to pick up. It's taking its time. There we go. So hydrogen for rail has a number of challenges, and actually what's quite interesting is that both Russell, Stephen and David have already talked about quite a few of the key challenges that are there for hydrogen and rail. And actually what we see is that the road market is quite ahead of rail at the moment, and that's generating some benefits, but also then obviously in terms of a technology standpoint. But then actually as we look forward for rail's got to play catch up really. Rail is a long bird industry. Many of you guys obviously been in rail many years, and you know how long it takes to get these things moved forward. TP Group's been working with the defence industry for easily 50 odd plus years, so we're very used to the fact that planning tends to take a long time, and I think there is now a real focus on how you need to plan for things here and now. There are a lot of legacy issues in the rail network. Again, looking through what's happening in the rail sector, if you start to look at hydrogen trains, you've got challenges around where do you put high pressure cylinders, what happens as you operate the trains. For instance, if they end up in a tunnel, what happens there? We've got to make these systems safe. And even if we look at the economics, Stephen's mentioned some figures there, some very good figures around hydrogen, the cost of hydrogen. And what we find is that early adoption of hydrogen solutions, particularly green hydrogen solutions, is very, very dependent on the cost of electricity to feed into things like electrolyzers. 70% of the cost is related to the electricity cost. So actually, to get to green hydrogen for rail, we've really got to look at how we site renewables close to systems. So TP Group and hydrogen. Well, TP Group, as I said, we've been working in the defence sector. We've been supplying electrolyzer technologies and carbon capture systems into the submarine programs, nuclear submarine programs, for many years. So we're used to working on developing really safe systems and our electrolyzers have uptime of about 98%. They have to have, because they're generating the oxygen people breathe, they're generating hydrogen that we deal with on board in a safe manner. We've developed a range of technologies to manage hydrogen in those environments, because you can't leave equipment with high pressure hydrogen sitting in it when you have a lockdown or emergency shutdown situation. We've been operating these technologies through life and supporting our customer, the MOD, and other customers similar to them, and keeping systems working. So our experience is very much around high reliability, making systems safe, and making sure people know how they're operating. In terms of the rail sector, what we've taken as a strategy to develop with partners. So we've partnered with Vanguard Sustainable Transport Solutions and Fuel Cell Systems. Both those guys worked on the Hydroflex train, and we're bringing to market hydrogen refueling technologies for the rail industry, something that's been designed in other markets, and we're bringing that technology across. So TP Group is a UK business. We've got over 63 years of manufacturing experience in the UK. We've been working across nuclear, defence, oil and gas, aerospace, and we have worked in rail through a business we acquired earlier this year. We have safety consultancy businesses. We have hydrogen safety experience through our work in defence, and we're very used to running complex programs. To give you an example, some of the programs we run are about £20 million, and they run across multi-year. So I think there's a good fit between TP Group and the rail industry in terms of the size and scale of the type of programs, but also some of the challenges. And TP Group brings across its experience from multi-sectors into rail to enable us to get to that decarbonisation challenge. TP Group is looking to embed a hydrogen refueling technology, and as we embed hydrogen fueling technologies, we're looking at the dispensation, we're looking at the storage, we're looking at the electrolyzer generation, which is core technology to us. We're also looking at control, and we have digital solutions as well, where what we're looking at with digital solutions is how do you operate these systems in a not only a safe and clever manner, but can we look at how we embed decarbonisation in there? So one of the earlier presentations, one of the speakers was talking about, how do we operate things differently? And I think those are kind of the areas TP Group's focused on. But our core offering into this sector will be with hydrogen refueling systems. So I'm open to take any questions in the Q&A panel. I think I've probably finished quite early, actually. But I think that's the exciting thing I see. And if I draw on how many people are saying the same kind of things on presentations today, it resonates really strongly with us. TP Group's probably not a particularly well-known brand name, purely because we've been working in those clandestine sectors for a long time. So we're keen to talk to many people in the industry and see how we can work together to deliver these things.
Thank you, John. We at RIA absolutely welcome suppliers like yourselves who bring real expertise from other sectors, practical stuff. As you say, looking at electrolyzers on nuclear submarines, that's a pretty important issue. So great. So thank you. That completes our presentations. We're on to the Q&A. Thank you, delegates, for banging in loads of really good questions. I want to ask all the presenters, please, can you bring up your cameras and microphones and join back in for this session? So I'd like to see everybody taking part. Just for the audience's benefit, Will Drury has not been able to stay with us for the Q&A. And of course, Andrew wasn't present in the first place, but thank you to Yulia Lorenzini and James Wright of RSSB, who are joining us, and hopefully they've also enabled their cameras and microphones as well. So just to pull together a group of questions really about battery trains, battery multiple units. Louise Shaw and John Seddon ask about modelling for battery EMUs. There's a big interplay here between the battery type, the characteristics of the route, but we don't have a standard basis for comparability, and perhaps we don't necessarily have a model or a benchmark. So particularly interested, perhaps David Golightly, is that something that you are near or something that you can see?
Absolutely, and indeed, I guess you're getting to why we are going to collaborate with somebody like Loughborough. The idea would be that somebody like Loughborough would generate that kind of reference model, but by us working with them and applying FMU and co-simulation, we would open that reference modeling up so it's flexible, so people can trial different options, such as trialing different batteries within there. And batteries is a really good example of why battery producers quite often want to protect their IP. They want to keep the secret source of how they get their battery to perform hidden. So there's the opportunity there to use FMI. It keeps the innards of their battery protected, and they can trial that out in different reference models.
Okay, thank you. And Stephen Kent, yeah.
I was just going to say, and there are, I feel like, slightly more traditional ways of using simulation. We have an operational simulator called Brave, which is intended to model all aspects of a line or indeed an entire network, which includes energy modeling. And if you link that in with various other things like just basic Excel analysis, you can come to some fairly sensible conclusions as to whether a battery with a given set of characteristics will suit and will serve a particular service on a particular line or indeed across a particular network. So there are, if you like, some more traditional simulation options available as well to solve that very problem.
Thank you, Stephen. And Rebecca, have you been working close to this area in terms of modelling of performance and range on battery vehicles across a range of routes?
No, I haven't done that on battery vehicles, no, but I was looking more at the life cycle performance on batteries. We've done lots of modelling on the flywheel, the RSSB project that we did in order to, it was a very similar methodology to that adopted by the Loughborough guys and their approach that was at the decarbonisation seminar earlier in the week, of going out and measuring what happens and then fitting our model to the energy performance and then seeing how that would deliver that 30%
Is the
reduction we found.
Is the flywheel mechanical energy storage, or is it electrical like the Williams?
No, it's not like any of those. If you look at a perspective of flywheels, you say at the one end you have Parry People Mover, which is a superb, huge lump of metal, which goes around slowly, and it's a classic, loads of inertia, and it's got loads of steel in it. And then the opposite end, you've got composite flywheels, which are kind of almost contradiction in terms because they're lightweight, and you need weight for the inertia to go. So they go at very high revs, and this is in the middle of that perspective, and it's made out of sheets of laminated steel, and it goes medium revs and medium revs, and it's all kind of scalable. And the one that we made so far is a 100 kilowatt one, and it's also been applied in some Formula One stuff with a very small one. That was the first one that we did, and then I got involved and we looked at the 100 kilowatt one for the RSSB application, looking at that DMU supporting an engine to downsize it a bit. So yeah, there was a modelling around that piece, obviously, to
if we can extend this, so thank you, Rebecca. If we can extend this to James and Yulia, looking at a forward programme of decarbonisation research, how can the supply chain best engage with RSSB to put forward areas for research? So, for example, battery range and battery comparability and battery modelling. What plans do you have there, and how can industry best engage with you? So James, I think you're volunteering, but you need to bring your mic up, James.
Yeah. I know that Andrew has in consideration a project to look at standards around hydrogen and batteries, whether that's performance related or more sort of safety standards. We'll need to clarify, but there may also be something on the competition front. I don't know if Julia can help there, if that's a route in.
In terms of competitions at the moment, there's nothing that we have announced, but that doesn't mean that we won't be able to do something in the future for sure. I guess the best way for suppliers and anyone interested in doing research with us, the best thing would be to contact us if you've got an idea, especially if it's supported by an industry stakeholder, train operator, Network Rail, or Roscoe, to get in touch either with ourselves or Andrew directly, and we can have a conversation and see whether that can be part of the plan going forward. We have a grant scheme also available, so there are a few ways in.
Okay, thank you very much. We've seen certainly a preponderance of interest and presentations covering hydrogen. Some really encouraging presentations on all aspects of, and thinking about the life cycle, so particularly the Tisley energy part there, picking up on the life cycle. So pulling together all those thoughts and the issues presented, what do we think is the one thing that needs to happen to make a really big step forward with hydrogen? And I guess, David Horsfall, would you like to give us your view on it? You're doing the practical development there.
Yeah, good question. I'd say if we could all just sort of go back to basics and start thinking about the energy system and agreeing an energy strategy which maybe understands what assets we've got at the moment, how they could contribute towards an energy system, but also having an energy strategy which gives confidence to developers, the sort of ones I'm alluding to, who are about to start building plants, who at the moment think the only way I'm going to get funding for this is if I inject that power into the grid. If they know as a city or with partners like the rail industry, they know there's an offtake for large amounts of hydrogen, they will invest in infrastructure which is geared up to producing hydrogen. So that's what I'd say. We kind of need that at region, citywide level, and we all need to feed into it. We all need to agree that's the right way to go. And there's probably nuances that aren't, it's hydrogen and heat and other places that have a large renewable power requirement. But that really needs to start with this strategy, which understands the holistic energy system and how this fits within it.
Thank you. Russell Fowler, what do you think from a grid point of view? What's the one thing that's going to really push hydrogen forward?
Well, I have to agree with David there. Having that overall industry strategy is essential there. You need that signal for investors. You need that signal for the grid to be able to invest there. So absolutely agree there. I suppose from an energy network point of view, we have that kind of short medium term saying we're going to look at kind of green hydrogen. We're going to look for electrolysis there. And what are those barriers there? David's mentioned kind of grid connection costs as well. What can we do to overcome those? Are there regulatory barriers that we need to overcome of looking about where does the cost? It currently falls on the kind of the energy connectee to do that. Are there things we can do where maybe that cost gets distributed onto, say, taxpayers or maybe energy bill payers? All these things need to be looked at. I'm not advocating any of these models in particular, but we certainly have to look at that as well to make sure that funding for those connections is fair. And if you're looking at long term as well, you have the electrolysis as well. What's your long term hydrogen strategy? Are we serious about kind of CCS and then developing that and creating large quantities of hydrogen there for heat that can potentially go into transport as well there? So I think there's a long-term lens of that and there's a short-term lens. So we're aware of those kind of short-term barriers about how you get those connections in and what you can do about that. So looking at that from a strategic point of view and then kind of focusing that from an energy and an energy connection cost point of view, I think is the way to do it. And if you look very briefly on what's happened on cars and charging hubs, for example, that has been noted that there is a bit of a kind of a barrier and a market failure there, and government has intervened with funds there as an infrastructure fund as well. So there is a rate there if kind of we can demonstrate that there is that barrier, there is potential to have funds available, especially if you're looking at kind of green recovery and build back better. So there is potentially an opportunity to get that there. But again, it needs to be fit with a kind of a strategy behind it to be able to justify the investment that you would need from government there.
Super, thank you, Russell. I mean, I'm glad we need to link into government policy, don't we? It's not just one way. It's got to be a two-way exchange of information. John Constable, you come in with a bunch of experience in other markets on working with hydrogen, and you've spent some time, I know now, looking at rail as a new market for TP Group. What's your feeling looking in? What would your advice be? What one thing do we need to sort out to get ourselves to really make a breakthrough?
Yeah, I mean, it's an interesting question. I think there's a whole load of things, isn't there? I mean, trying to pick one thing that we need to do differently, I think it's the economic models, if I'm honest. So green hydrogen, the green versus blue hydrogen is a key area, and we work in both green and blue. I have technologies in those areas. Blue hydrogen is really good for heating networks and for non-transport applications in many ways, because the purity level doesn't matter. When you start talking about transportation devices, you start talking about the purity of hydrogen. Electrolysis can provide ultra pure hydrogen, but the challenge is the economics around that in terms of electrolysis technology today is relatively small scale. I mean, we look at the figures put together today, and we're talking about 3 tons for train networks, 10 megawatt electrolyzers. Well, I would imagine that actually we need to be scaling up from 10 to 20 to 50 megawatts of electrolysis in plants somewhere to do that. And that may be distributed, that may be centralized, but the cost signature of the electricity that comes in to generate that is where the challenge comes. So for me, I think it's all about the strategies around economics. You know, is it possible to give electrolysis some tax breaks, some benefits, a bit similar to what red diesel gets? You know, are there carbon taxes go on diesel, for instance, or on other technologies, which, you know, it's not great for us as a car driver maybe, but I think in terms of trying to take us towards net zero, those kind of things. So for me, I think looking outside in is the economic model is the challenge with it. And I think the early adoption projects will clearly not disregard the economic model, but they'll accept the economic model to make this happen.
Super, John, thank you. That's the outside in. Stephen Kent, you've been working miracles with getting a hydrogen running on the main line. I mean, people said it couldn't be done, and you've done it. So good on you.
Yeah, the university has. Yes. One thing, just to build on the comments just by John there. Strangely, green hydrogen for rail applications doesn't benefit from RTFO credits, which seems a bit of an odd thing when other sectors do. So if we could please have RTFO credits for John, can you help me with what that stands for? Renewable transport fuel
got a minute,
so that would definitely help, but we need there are various franchises or were franchises who have plans ready to go. We just need somebody to hit the button and say, yes, we're going to run a fleet of 10 hydrogen trains up and down this network, and then private industry will look after the whole supply of the hydrogen side of things if we can agree a fair price on it.
Yeah, it's getting the incentives right. So we have to wrap there, I'm afraid, but thank you everybody for taking part in that, for your contributions. Thanks again to all our speakers today. Thank you very much. To our partners at Network Rail, Ukraine and RSSB, to my colleagues, Milda, Hannah and Trevor, who've produced the event and really shepherded it through this week. They've been working really hard in the background. Of course, all our delegates are coming along and taking part. Thanks again to everybody, and we'll see you for the next Unlocking Innovation event in the week commencing 14th of December, where we're going to be looking at light and very light rail, which is a really intriguing new area where things are moving on very quickly all of a sudden. So thanks again, everybody, and we hope to see you working all the developments that come from the relationships built up today. Thanks very much indeed.